Welcome to another video. Let's walk through this math challenge on the board. If t equals tan x over 2, find the values of t which satisfy this equation. So our task is to find the values of t which satisfy this equation, where a is a non-zero constant. And also we are asked to find two acute angles which satisfy the equation when a is equals to 1 over radical 3. All right, so what I will do first is to express sin x and cos x, okay, in terms of tan x over 2. Okay, that's one of the many ways, to solve problems like this, because our task is to find the values of t. So to find the values of t, okay, so I'm going to express sin x and cos x in terms of tan x over 2. Okay, all right. So now another thing is, now we know that if we use a right angle triangle, okay, a right angle triangle where the given angle is x over 2 according to the question, and we know that if we have tan x over 2 to be equals to t, so this is same as, we can write this as a fraction to be t over 1. Okay, this will be t over 1. So which means for tan x over 2, according to the definition for tangent, which is opposite over adjacent, so this will be t, this will be t, then this will be 1. So this is the opposite, which is the side, okay, the side which is directly opposite the given angle, then the side which is beside the given angle, that's the adjacent. So now the hypotenuse, which is the longest side in a right angle triangle, this will be square root of 1 plus t squared. So which means for sin x over 2, it will be t divided by square root of 1 plus t squared. Okay, then for cos x over 2, it will be 1 over square root of 1 plus t squared. Okay, but for sin x, okay, the expression for sin x in terms of t will be 2t divided by 1 plus t squared. Of course, we can derive this, okay? Then also for cos x, the expression will be 1 minus t squared divided by 1 plus t squared. Okay, because even from one of the identities, trigonometric identities, we know that 2 tan x that's 2 tan x over 2 divided by 1 plus tan x over 2 raised to the power of 2 will be equals to sin x. Okay, then for cos x, it will be 1 minus tan x over 2 raised to the power of 2, then divided by 1 plus tan x over 2 raised to the power of 2, or raised to the squared of tan x over 2. All right, so now I'm going to substitute these expressions into the equations the equation we are given. Okay, substituting these expressions, okay, into the given equation, okay. What is the given equation? We have parentheses a plus 2 sin x plus parentheses 2a minus 1 cos x equals to 2a plus 1. Okay, so now we know that sin x is equals to 2t over 1 plus t squared. So this will be a plus 2, okay, multiplied by 2t divided by 1 plus t squared, then plus parentheses 2a minus 1, okay, multiplied by cos x is 1 minus t squared over 1 plus t squared, and this will be equals to what we have here, that is 2a plus 1. Now, so what to do what to do from here is to get rid of 1 plus t squared. Okay, that is, I want this, that is, in order to get a straight equation, that is a linear, that's a straight equation. Okay, so which means I'm going to multiply both sides by 1 plus t squared. Okay, multiplying both sides by 1 plus t squared. Okay, so we're going to obtain, for the, now multiplying this by 1 plus t squared, we're going to have, this will reduce to 2t parenthesis a plus 2, then plus multiplying this by 1 plus t squared, then this will reduce to parenthesis 2a minus 1 multiplied by 1 minus t squared equals to parenthesis 2a plus 1 multiplied by 1 plus t squared. Now I can remove the parentheses, okay, so that for the first one, we're going to have 2at, then 2t multiplied by 2. This will be 4t. 2t multiplied by 2, that's 4t. Then for this, we're going to have, this is 2t, we have 2at plus 4t, then plus 2a times 1. This will be 2a multiplied by negative t squared. This will be minus 2at squared. Okay, negative 1 times 1, that will be negative 1. Negative 1 multiplied by negative t squared. This will be positive t squared. So on the right side, we're going to have 2a times 1. This will be 2a. 2a multiplied by t squared. This will be 2at squared. 1 times 1. This will be 1. Then 1 multiplied by t squared. This will be t squared. Okay. Now I can simplify. We need to simplify this so that this will be, now we have 4t. This is 2a. So 2a cancels on both sides, from both sides, okay? Then also t squared cancels from what? From both sides. Then we're going to have on the left side will be 2at plus 4t, then minus 2at squared minus 1. And this will be equals to 2at squared plus 1. Okay, now I'm going to move everything here to the right side, right-hand side of the equation. So that to the right side of the equation, we're going to have 2at squared. Okay, so when this comes here, it becomes 2 plus 2at squared. Now 2at, when it goes to the other side, it becomes negative 2at. Then 4t, okay, when it goes to the other side, it becomes minus 4t. Then negative 1 goes to the other side to become plus 1. And also we have plus 1 here. So this will be plus 1 equals to 0. All right, so this becomes 4at squared. Then minus 2at minus 4t plus 2 equals to 0. All right, so now then I can also reduce this equation again by dividing through the, that's dividing by dividing both sides by 2. Okay, so let me divide both sides by 2. So dividing this by 2, the equation by 2, we're going to have 2at squared minus at minus 2t plus 1 equals to 0. Equals to 0. All right, so in this case, we're going to have at is common. So at parenthesis 2t minus 1. 2t minus 1. This will be equals to, this will be minus parenthesis 2t minus 1 equals to 0. That is at times 2t. That will be 2, that will give us 2at squared. Okay, then at multiplied by negative 1. That will be negative 80. Then negative 1. Okay, that is the number that precedes the parenthesis will be minus 1. So minus 1 multiplied by 2t, that will be minus 2t. Then negative 1 or minus 1 multiplied by negative 1, that will be positive 1. Then equals to 0. So what we have here is we have this equation, and this will be at minus 1 multiplied by 2t minus 1 equals to 0. So we have what we call zero products. We're going to apply zero product identity in this case. So this will be at minus 1 equals 0, or 2t minus 1 equals 0. So that from here we can say that at equals to 1, then t equals to 1 over a. Or this will be 2t equals to 1, then t equals to 1 over 2. So these are the two values of t, okay, which satisfy the given equation. The two values of t that satisfy the given equation. All right, so hence we are asked to find two acute angles, okay, acute angles which satisfy the equation when a equals 1 over root 3. All right, so now to find two acute angles, okay, to find two acute angles satisfying the equation, okay, satisfying the equation, then it means first we know that we have t equals to 1 over a, and now that is when a equals, when a is equals 1 over root 3, when a equals 1 over root 3. So it means that from here we can have t to be equals to 1 over radical 3. Now let's recall, we know that t is equals to tan x over 2. So recall, t equals tan x over 2. So it means that this will be tan x over 2 equals to 1 over radical 3. So I'm going to take the inverse tan of both sides. So that this will be the inverse tan of tan x over 2 will be equals to the inverse tan of 1 over root 3. The inverse tan of 1 over root 3. Let me continue from here. So, which means what we have, so this will reduce to x over 2 equals to inverse tan of 1 over root 3. So the inverse tan of 1 over root 3 will be 30 degrees. So this will be x over 2 equals to 30 degrees. So the first acute angle will be 60 degrees. So 2 times 30, so x equals to 60 degrees. So now let's calculate, let's also calculate the second angle. So we have t equals to 1 over 2. So this will be, and we know that t is equals to tan x over 2. So it means that tan x over 2 will be equals to 1 over 2. So if I take the inverse tan, okay, if I take the inverse tan of both sides, so the inverse tan of tan x over 2 will be equals to x over 2. So this reduced to x over 2. Why this becomes, this is inverse tan of 0.5. Inverse tan of 0.5. So that x will be, this will be 2 inverse tan of 0.5. Then the value of x, okay, will be 53.13. So therefore, the two acute angles, okay, the two acute angles are, so I can put this first, and 60 degrees. So these are the two acute angles, okay, angles which satisfy this equation, that is the given equation. And with that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.